1/6 x to the power of 4.
Mm-hmm.
And you get -4 to the power of 3/2. -4x to the power of 3/2.
Good.
Plus 1x plus c.
It's grand. Okay. Okay. How do we do question 2?
So it wants the integration of the top one, but it has to be like within 2√2 and 1.
Mm-hmm.
So you substitute 2√2 for x, right?
Only into the integral.
Okay. So can 12/x² become 12x to the -2?
Yeah.
Okay. You go x to x².
Yep.
Plus 3x. -12x to the -1.
Minus 12x to the -1. Okay, and then?
You sub in 2√2 for x.
So.
And then you do minus, and then sub in 1 for x in the equation as well.
So 2√2 for x. So this is how you show you're working out. So 2√2 instead of all the x's.
Yeah.
And then you subtract, just put it in a bracket, every thing, the other one. So 1 instead of all the x's. And in fact, I can just put like 1² plus 3 minus 12 minus 1. However, I hear you tap it.
Yeah.
That'll work out. What you can also do is just, if you press the integration button, it'll just save you some. Oh, no, sorry. We can't, because show that this is equal to this. So they gave us the answer. Usually that just into putting in the function. So 2 x plus 3 plus 12 over x², and that's between 1 and 2√2. Problem is it gives us the decimal, and I'm sure that that's the same. So if I put in 16 plus 3√2 SD, it is the same, but how do we show it? What you have to do is do these separately. So like what?
Okay. Yeah.
So let's say 2√2 squared. So that's 8. Okay, that's not bad.
Okay.
This one.
That's 6√2.
That is 6√2. I'll see this one to the -1. So that is 6√2 minus 3√2. And then this whole bracket here, you'd put that in, and then you could write at the end, 16 plus 3√2. Yeah, so if it wasn't an exact value or something like that, you could do the simpler way and just pinky promise that you put that whole crazy thing into your calculator. Unfortunately, they kind of thwarted that. So it's quite common that you have to put in, especially the weirder ones like 12 times 2 root 2 to the minus 1, that you have to kind of manually do that stuff and then just combine them.
Yeah.
Yep. All right. Oh, well, 3.
Should be x to the power of minus x, right?
Well, that could be written as 4x to the minus 3.
Oh yeah. Oh yes. It'd be 4 minus 2x to the power of minus 2. Plus 2kx squared.
I believe 1 over 2 kx squared. So that's like 1 kx divided by new power.
Oh, you divide by 2. Yeah. So yeah.
And
Plus c.
plus 8. Well done. Part B.
So can we use the integral we just got and sub in 2 and 0.5x?
Yes. So minus 2. So we sub in 2. We don't have k.
Yeah.
And then c minus c is always 0, so we don't need to worry about that. Minus what we get when we sub in 0.5. Okay. We have to solve for k.
Okay. And it says equal to 8.
Oh yeah, it's equal to 8. So that whole thing is equal to 8. Okay. What's next?
It's probably easier if we simplify the left.
Yep.
Okay. So you get minus a half for the first part.
Okay.
Yep. Add a half. Wait, could you multiply, the 2 on the right side of the k? Could you multiply that by the half?
Bidmus index first.
And as in, like, once you've got the index, like, form of it. So
Right.
you get 4. Could you multiply the 4 with the half?
Yeah.
You'd get 2. It's 2k.
Yeah.
And then minus. You get minus 8. Well, minus 8.
So minus, I'll just put it all in the bracket.
Yeah. You get 8k.
So plus 8k.
8th, sorry.
Oh, 1/8.
An eighth.
Okay.
Yeah, 1/8.
Okay. How do we solve?
And then you can simplify that down to. Should we get rid of the bracket now? It'll be easier.
Yeah.
So you get. It'll become like 8. It'll be plus 8 now. And then plus 1 over 8k equals 8.
Plus times minus.
Oh, right. Yeah, so it's 1 over 8. Minus 1 over 8k.
Yeah.
And then you can add 8 and minus a half, which would give you 7.5.
Yeah.
And then you could add the 2 and the 1/8. Or minus 1/8. That gives you 15 over 8 k.
15 over 8k.
Equals 8. And then you can minus 7.5 on both sides.
Sure.
And you get a half on the right. And then you divide by 15 over 8 on both sides.
Okay.
And you get 4 over 15 equals k.
So 4 over 15. And I'm going to put this entire thing from the beginning. Maybe I went wrong somewhere. Answer. 4 over 15?
Yep.
Yep. So k equals 4 over 15. That's great. So let me cheat very much. Will that work? No, it won't. Yeah, so you know what you're doing. It's just long, pretty long and difficult, brutal stuff. Okay, let's see this one. This time the unknown is what you're subbing in, but I think it's the same idea really.
Yeah.
You would integrate and then you end up with like subbing in the k for x and then 1 for x, but the unknown is in there.
Yeah.
Hence using algebra find any values. Yeah, okay. It turns out it's a quadratic. Alright, how about this one? What is that? Yeah, how about this?
Alright. So for this, do we want to make the integration equal to 8? But it doesn't work like that, does it? Because the area under a graph is differentiation.
So the area under graph is integration?
That's integration.
Gradient is differentiation.
Oh yeah, gradient differentiation.
So the integral
10, right?
is equal to 10. Between what and what?
1 and 1.
That'd be 0.
Oh no, wait, no, 8 and 1. No, A and 1. Yeah.
A and 1.
Yeah.
Yeah. Okay.
So make root 8x.
Hold on. This is the equation of the graph. Y equals root x.
And the integral over there says 8x.
Don't worry about that integral. What is A? So the region has an area of 10. So the integral of y, this y, with respect to x, between A and 1 is 10.
How should make it the integral of root x, because y is root x,
Yeah.
dx equals 10.
Yeah.
And then would you integrate root x?
Yeah.
Would you just get x?
How do you write? Root x is the same
Oh
as.
wait, no, it's the x to the half.
Yeah.
Okay. You get 2 over 3x to the power of 2 over 3.
3/2.
3 over 2. Oh, yeah.
Yeah. So that's between a and 1.
And then you sub in a for x and 1 for x.
Sub in 1. I think it's just 1, is it?
I'm checking. It gives you a bunch of decimals.
Is it 2/3? Is it 0.6 recurring?
It's 0.544331054.
And what did you put into your calculator?
Oh, I know you need to do indices first, that's why.
Yeah, but just put the whole thing in. Don't worry about.
Okay. And that gives you 2 over 3.
Yep. Okay.
And then do the 2 over 3 is going to cancel out.
Nope. Bidmas.
Oh, it's because it's multiplying, isn't it? So could you add 2 over 3 on both sides?
Yep. So that's 10 and 2/3. That's still there.
32 over 33.
What is it, sorry?
32 over 33. Oh no, 32 over 3, sorry.
Yeah. 32 over 3. Nexty.
And then you can divide by 2 over 3.
Yeah.
And you get 16.
So a to the 3/2 equals 16.
And then when you want to use ln,
It's crazy enough to work, yeah.
or could you just root by 3 over 2?
Let's go with logs.
Okay.
So ln is specifically for e, so let's just go with log.
Okay.
You know what? Let's go with ln. Ln
Okay.
a 3/2 equals ln 16. Oh wait, no. That's for when if the unknown is in the power.
Yeah.
3/2. What's that the same as?
Well, what do you mean by like what's the same?
So like another way to write it would be a to the half to the 3.
Yeah.
And so how can you solve that?
Look at your cube root both sides.
Yep.
Okay. You get 2.51984 on the right.
All right. And then
you can just root by a half.
yeah, square both sides.
Or square both sides.
I think that's the same as the half the root.
And does that become root 16?
So, no. Square both sides. So let's say like 16 squared.
Oh, okay.
And the cube root of that. Let me just see something. Cube root of 16 squared. All right, 6 point something. All right. So then how would we do part 1?
Would we sub in what we got for A?
Yeah.
Sub like 6.3496 or something.
Yeah. Something's not sitting well with me with that answer though. Let me see. So we did. Do I have the answer? Well, maybe, I don't know. Integration. I do. So that's the K stuff. What question is this? 5? (32/3). So it's A is 2 to the 8/3. It's the same thing.
Yeah.
All right, it is correct. It's the same as what we did. All right, integrate square root of 8x.
Okay. So the square root of 8x become like 8 to the half.
It's like 8 to the half x to the half.
Okay.
So what's the integral of that?
Okay. So you get 3/2, 8. Right, is it, you multiply the coefficient, right? I know you divide. So 2/3, 8. Or just 2/... Oh no, you multiply by 8, don't you?
You multiply by 8 to the half.
Yeah. No, you multiply 3/2 by 8.
No. Just, all right, calculator. What's 8 to the half?
A bunch of numbers.
Oh yeah. All right, so it's gonna be 8 to the half divided by 3/2.
Yeah.
And so what is that?
That gives you a bunch of numbers. 8 to the half, and then divide by 3/2.
So divide by 3/2. Keep change flip 2. So 2 times 8 to the half. That's over 3. And that's x to the 3/2. All right. You sub in A, sub in 1. Take away, get your answer. Not feeling that question. It's wacky stuff. All right. Factor theorem. Product of 3 So they're marrying that up with factor theorem. The finite region is bounded by this curve. All right. How about this? So any idea how we do these?
So do we want to make it like 2 brackets x minus 5 cubed?
No.
That's a long division.
It says use the factor theorem. So imagine this was like some quadratic from GCSE.
Yep.
X plus 3 or something. If you subbed in 5 for x,
Yep.
what would you get?
8.
This is minus.
It'd be 5 minus 5, which is 0. Oh, 0 multiplied. Oh, it'd be, yeah.
Yeah.
So it's 0.
So that would be 0. So to show that x minus 5 is a factor, you sub in 5 for x.
Okay.
And so what do you get?
How come it's not minus 5?
This one wasn't minus 5, like x minus 5. So it's like x minus 5 equals 0.
Yeah.
If x minus 5 is a factor, then x equals 5 is a solution.
Okay.
So minus 41 times 5 minus 70. If it's a factor, do you know what you get when you sub in 5 into that thing?
You get 0, right? Except for minus 70.
You get 0 for the whole thing, including
Oh.
minus 70.
Okay.
Therefore, x minus 5 is a factor.
Yep.
That's it, using the factor theorem. Just like this one up here. So for this kind of GCSE question,
Yeah.
if x plus 3 is a factor, then what would you sub in to show that it's a factor?
You put 3 in.
That would make 6.
Oh, minus 3.
Minus 3, yeah. That's how it works.
Wait, so if the question said show that x is like divisible by x plus 5, would you put in minus 5 for x?
What is minus 5 minus 5?
No, I meant like if it was x plus 5.
Yeah, exactly.
Okay, yeah.
Yeah, it's basically the factor is equal to 0.
Okay.
And you solve it. Part B.
And so would you need to just solve it as a cubic?
Yeah, what do you get?
Okay. And you get x can either be 5 minus 2 or minus 7 over 2.
Minus 2?
5 minus 2 and minus 7 over 2.
Alright. What do you do with those?
Do you make them not equal to x?
Yep. Go
You
on.
make them like x minus 5 equals 0.
Yeah.
X plus 2 equals 0. X plus 7 over 2 equals 0.
Yeah. What's next?
Do you put them all in brackets next to each other?
So that's going to be x plus 5. That's going to be x plus 2. Fraction. These can't be fractions. They have to be whole
Oh,
numbers.
yes, so you multiply both sides by 2.
So what do you
You
get?
get 2x plus 7 equals 0.
That's 2x plus 7. That one's x plus 2. That one's x minus 5. And they gave us this x minus 5 bracket. Multiply that by the x plus 2 bracket. What do you get? Oh no, hold on. They gave us the x minus 5 bracket. Multiply the other two together.
Would it be 3x squared?
2x squared.
2x squared. Plus 7x.
Yep.
And then plus 4x.
Yeah, 7, 8, 9, 10, 11. Yep.
And then plus 14.
That's it. Okay, so we've tricked them. We worked backwards. So I wrote it all backwards so that they gave us x minus 5, and in our head we factorized to get the second bracket.
Yeah.
We then factorized this second bracket, and this is our answer right here. That's our full marks, and then we actually solved it for the roots, but the examiner will say this part is unnecessary but doesn't affect it. That little trick, that's so we don't have to do long division and stuff. Part C.
Okay. So you'd integrate at the thing at the top, gx.
Let me see. The finite region is bounded by the curve, and the you're so right. Yeah, this A and B wasn't necessary for C at all. Hang on. The finite region is bounded by the curve of this equation, and the x-axis, the value of r. So after you integrate it, what do you do? We did need to integrate it. Oh, we did need to do A and B, yeah.
Wait, so we don't need to integrate?
No, we did need to do
Okay.
A and B. So then you'd integrate it. So let's see, that's a half x to the 4 plus a third x cubed minus 41 over 2x squared minus 70x. Okay, but between what and what? The region by the x-axis and lies below the x-axis.
Yeah.
Any idea about that?
It'd be negative.
Well, we have to basically sketch this. This is a cubic. Okay. So how would you sketch this graph?
Would it go from bottom left up?
So bottom left, yeah. Where does it cut through the axes?
Wait, oh yeah, we got them down. Is it? It's one of them 5. One of them's -2. One of them's -7/2.
-2. -7/2.
Oh no, 7/2. Yeah, 7/2. -7/2.
So that's -3 point something. So I'll be to the left. So I'll make that one -7/2. That one's -2. Y-intercept?
The y-intercept is 0.
It's when x is 0.
So it's -70.
So it's -70. So all the way down there. So we start bottom left.
Yep.
And it's going to be something like that.
Yep.
Okay, so we want to integrate between what and what? We want the area between the x-axis and below the x-axis.
Oh. So it'd be -2 and 5.
Yeah, and so you'd sub in 5 and sub in -2.
Yeah.
So that's why we needed to do that. If you're really stuck, hang on. Graphical calculator.
Yeah.
Let's see. Let's put this in. 5 for graph. 2x cubed plus x squared minus 41x minus 70. That's what she looks like. Let's see.
Yeah.
Normal. Is that normal? That's okay. Shift. That's not bad. Let me see. Graphical solve. If I press right, and we have the integral of dx f3. Intersect. Let's see what happens there. Yeah, I'm not going to mess around with that. Just basically, I can see there, that's -2 and that's 5. 1,
Yeah.
2, 3, 4, 5. Yeah, that's good. Okay, and so if you're having difficulty sketching the graph, okay, that was a big one, tricky. All right, yeah, this looks good. I remember this one. Yeah, how about this?
So, would you need to integrate the equation first?
Oh, excuse me. Yep.
Okay.
What would you do after you integrate it?
You make it equal to 256 over 3.
Show that. Can't use that number.
Okay. So we want to make it between 0 and k, the integration.
Yeah.
Then you'd solve it by subputting them in for x.
You have to figure out what k is, though. And you're told that it's a minimum turning point.
So it has to be negative, right?
What do you know about a minimum turning point, or what do you know about a turning point in general?
Oh, the gradient 0.
Yeah. How do you get gradient of a curve?
Differentiation.
Yeah. Do it.
Okay. So you do differentiation of y equals, so it'd be uh 6x to the -2. No, to 2, sorry. Minus 34x plus 40.
Yeah.
And then, would you solve as a quadratic?
Yep.
And you get x is 4 or 5 over 3.
Okay, so which one is k?
Would it be x equals 4?
Yep, that's 4, and that up there is the 5 over 3. That's like
Yeah.
1 and 2/3. Yeah, and so our integral of that would be between 4 and 0, and you'd get your answer. And the answer you should get would be 256 over 3.
Yeah.
And you would have to actually sub in 4 and do all that. Let's see. Yes, it's a turning point, and so the derivative equals 0. So you have to do that to find k, and just check, yeah, 4 is to the right. That other one, the maximum turning point, is to the left.
Yeah.
Okay. Alright. So I can see already the trick in this. It says the exact value of the area, meaning that it's not going to be a nice number, and we can't use any shortcuts or tricks or anything.
Yeah.
Oops. Okay, how about this?
So do we want to first expand the bracket on the right? Well, in the y equals.
Yep, you'd fully expand those brackets.
Yep. You'd get a cubic.
Yeah, so that's x plus 3 times x squared minus 4x plus 4. Let's see, x cubed minus 4x squared plus 4x plus 3x squared minus 12x plus 12. X cubed minus x squared minus 8x plus 12. Okay. What's next?
Okay. Now we need to know what we need to differentiate to get the 2 points.
Yep.
In which the shaded point is in between.
Yep.
And then you do, so it become 3x to the minus to 2.
Mm-hmm.
Minus 2x to the power, just not to the power, and then minus 8. Then you'd solve as a quadratic. And you get x is either 2 or minus 4 over 3. So 2 is on the right, which is 1 on the bottom. And then minus 4 over 3 is on the left.
And then?
We can integrate and then put them into the integration. 4 and minus 2 and minus 4 over 3.
Yeah, that's correct. 2 and minus 4 over 3. And you get your answer.
Yep.
That's it. And one thing to watch out for with that, if I just go back, at the very start, we had to put these in individually.
Yeah.
Wherever it was. We had to put each one in individually because we were getting a square root number.
Yeah.
And so you have to do the same with this one. They said an exact area, which tells me you're going to get some kind of square root thing going on.
Yeah.
And so just watch out for that. Well, you might not, but it seems like they wouldn't say exact area if you didn't have to. Oi. Let's see this thing. Right. How about this?
Alright.
Yeah, they're not messing around.
So first, would you differentiate the equation?
Let's see. So, why would you do that?
You need to get the 2 points. Well, you already got one, and then you need the one on the right for the area of R.
If you differentiate it and make it equal to 0 and solve it, you will get the x-coordinate of the minimum. So you would just get like that thing there. Oh wait, maybe you're on something. But let me see. That's not correct. So differentiated.
Okay. Get minus 64 x to the minus 1
Okay.
plus 3.
Plus 3. Let's see. So that's dy dx. Let's see. So the point 46 is on C. The line L is the normal to C at the point P. So that point P is 46. What would be the gradient at the point P?
Would that be like the same as the one as the gradient of L?
It would be perpendicular to the gradient of L.
So it'd be the reciprocal.
Sure. How would you get the gradient though? At the point P?
Could you use y equals mx plus c?
You would use dy dx.
Okay. Wait, you subbing 4 for the x?
Yeah. Four, 32, 16, minus 16 plus 3, minus 13, I think.
Yeah, minus 13.
Okay,
And then it'd become 1 over 13.
well done. Bless you.
Thank you. And then we have the gradient first. So that's the gradient of p.
Gradient of L, yeah.
But is it not the gradient of p because it's a reciprocal?
P is just the point.
Ah.
Okay. Next thing.
Would you need to use y equals mx plus c for the line now?
Yep.
So could you do like 6 equals 1 over 13 times 4 plus c?
Yep.
Okay. You get 74 over 13 equals c.
Okay.
So now the equation for that is y equals 1 over 13x plus c. No, plus 74 over 13.
Yep. Nexty. How do you get this point there?
It intersects with the x-axis.
Yep. Meaning?
Would you need to find the reciprocal again?
Meaning y is 0. Y coordinate will be 0
Oh
there.
yeah, oh, so you can make y 0 in the equation.
Yep.
Okay.
And I believe you get x is, I'm getting a negative number. Expecting a positive number. 4, 6. Okay, so you'd make y 0. You'd get the x coordinate, and then that's what you would integrate. That's what you'd integrate between. Let's see. Just want to make sure. So 32. That's x to the minus 2. That should be to the minus 1. Yeah. Yeah. Plus 3. So we sub in. The gradient at that point is minus 13. It looks like it's positive to me. Is it just this? I think their diagram isn't good.
Yeah.
I think it's their diagram. 32 over x squared plus 3x minus 8. Yeah, I'm not going to bother with that. Yeah, you'd make y0, solve for x, and then integrate between those two.
Yeah.
There's a bit more work involved, but let's see. Let's leave it. Let's see. Integrate normal. That's all right. Yeah, so watch out for if there's square roots involved. You just have to do it manually. Anything to do with like exact, show that the area is this. You can't use that. You have to actually do it forward.
Yeah.
So this one, k, yeah, just make it equal to what they say and solve for k. That one, yeah, it was a weird one. Sure. Yeah, factors theorem. You'd make that factor equal to 0 and sub in the solution. Show that you get 0. Use calculator to solve it in reverse. And then, yeah, if it helps graphical calculator to see that it was between 5 and minus 2. But you use part B to do that as well.
Yeah.
The negative part. This one, yes. dy dx is 0 at a minimum and maximum. And so that'll give you those. That was similar, I think. Yeah. And then this one, yes. Dy dx gives you the gradient, and so perpendicular, negative reciprocal. How was that for you, Adam?
That's great.
So you have your test on Monday?
Yeah.
My fingers crossed for you.
Thank you.
And any questions for? So we'll do like stats and mechanics on Monday.
Yeah, Tuesday.
Tuesday, all right. Any questions in general?
No.
All right. Well done, Adam. You did great.
Thank you.
And yeah, good luck with the test.
Thank you. Have a nice weekend.
You too. Take care. Bye bye.